Today we are going to do some review, just looking at area of two-dimensional shapes that you've learned in the past. So we're going to start with rectangles. Hopefully you remember that the area formula for a rectangle is area equals length times width. And so when we're looking at our rectangle, remember our length and our width are the sides of the rectangle. So we've got our length here and we've got our width here. And so what we're going to do is we're always going to start by writing our formula, and then we're going to plug those numbers into our formula. So for our first example, we would have area equals 10 times 6. And then we can do our multiplication. 10 times 6 is 60. Now, after we have found the answer, we need to make sure we label our units. So our units, as we can see, are meters. And area is measured in square meters. Remember that means we're actually putting little tiny squares along our shape. Think of it like a bathroom floor that we're filling with tiles. So that means it would take 60 square tiles to cover that entire blue rectangle. The next shape that we're going to review today are triangles. And so you'll see in this picture that I have a parallelogram up first and a rectangle or square. And what I'm trying to show you here is that a parallelogram and a rectangle, if we cut those in half, we end up with two identical triangles. And so therefore, to find the area of the triangle, we just need to find the area of our rectangle and cut it in half. So our formula becomes area equals 1/2 base times height. Now the reason we say base and height is because when we're looking at our triangles, we have to find that right angle. Remember, in a rectangle, we have length times width. The length and the width are formed by the sides. Well, in a triangle like the right triangle in the middle, we still have our length and width. But if we look at our first triangle over here, the right angle is in the middle of the shape. So we tend to call that base and height. So the key is finding that right angle in our shape. So let's go ahead and do an example together. So here we have a triangle. And again, what we want to look for is we want to look for our right angle. So we can see our right angle right here. And so our base would be the bottom part of our rectangle, and the height would be the distance that's perpendicular, that goes straight up and down, making that right angle. And then to find our area, we simply plug those numbers into our formula. So we have 1/2 times our base 6 times our height 12. So you can multiply in any order that you want. I personally like to get rid of the fraction. So if one of my numbers is even, I like to multiply it by 1/2 really quickly just to get those numbers as small as possible. So this becomes 3 times 12. So our area is 36. Now notice on this shape, there's no units labeled. So we just write the word units squared. Okay, the next shape that we're going to look at today is a parallelogram. So remember back when we talked about parallelograms have two sets of parallel sides. So the top and the bottom are parallel, as well as the right and the left side are parallel. Now this is where we're using the formula base times height. So just like we just talked about in our triangle, we're looking for that right angle. So our base and our height are where we see the right angle. So that 5 and that 3. So let's go ahead and do an example. So again, we always start with our formula. So our formula, area equals base times height. Now we have to identify our base and our height. So our base, we look for this right angle symbol right here. And so our base in this shape would be the 2.5. And our height would be formed with the right angle. So that would be our 1.8. And at this point for the multiplication, it's okay to be using a calculator. And so we get, when we multiply those out, area equals 4.5 square meters. Okay, and then our very last shape that we are going to go ahead and talk about here is our trapezoid. And a trapezoid is when we actually take a parallelogram and we cut our parallelogram in half. And usually I do this experiment in front of you and I hold up a bunch of different parallelograms and I just randomly cut them. And every single time, without measuring or anything, they always give me two identical trapezoids, which is kind of cool. So there's a little trick to this though, because if you'll notice when I'm thinking about my original parallelogram, the base would be this entire length. However, when I cut it in half, right, I cut it in half along here, what ends up happening is my base, I've got this part here, but notice that that second section, this little piece over here, is not in my shape, it's actually over here. But what's really cool is that this side matches with that, and this side matches with the bottom. So what we can see happen is that that entire base just got split between the top and the bottom of our trapezoid. So what we do is we say that these are both the base of the original parallelogram, and we just say this is base part 1, this is base part 2. So when we're looking at our formula to get the original base, we have to add those two parts together, part 1 plus part 2. And that would be the base of our original parallelogram. Then the next thing we need to look at is we need to look at the height. And the height is going to be that perpendicular distance right here. So we'll see that going right there. That's our height. And our trapezoid is only half of the original shape. So we need to add the 1/2 in front. So let's look at an example. Again, the key, we always start by identifying our bases. Our bases are the parallel sides. So in this particular trapezoid, that would be the top and the bottom. And then we write our formula, area equals 1/2 base 1 plus base 2 times the height. So I'm going to start by plugging in those bases. So I have 1/2 times 22 plus 18. And then the height of my parallelogram is that distance going up and down in the middle of the shape where I see my right angle, and that would be 6. Now don't forget that we always have to follow order of operations. So when we're solving, we have to do that addition first. So we end up with 1/2 times 40 times 6. And I'm running out of space here, so I'm going to put my answer up at the top. So half of 40 is 20, and 20 times 6 is 120 square inches. So that was just a quick review on the 4 different shapes we're going to be using throughout the rest of this chapter and how to find their areas.